In example 3, we need to graph and analyze the following exponential equation. If we take a look at this equation, f of x is equal to negative 4 to the x minus 2 power minus 3. Got a few things going on here. One thing is we have a base of 4, so we'll need to know that. Also, we have a negative sign out in front of the 4, and so we know that we're going to have a reflection. The negative 2 is going to be a shift right 2 units. And then, that's what that guy does. And then the minus 3 will be a shift down by 3 units. So that's what the negative 3 is, okay? If we take a look at a normal y is equal to 4 to the x power, I'll write that over here on the right hand side. So y is equal to 4 to the x power. Here's what it's going to look like. It's definitely going to pass right here through 0, 1. 4 to the 0 power is 1. That one's good. Find the next point. Our base is 4, so we could take this distance and divide it by 4, and that would give us 1/4. 1/4 divided by 4 would be 1/16, and that would get really close to this line right here, but it wouldn't cross it though. It would just get very, very close. The right hand side, we want to go right 1 up 4. 4 to the first power is 4, and the next one, 4 squared, would be 16, and that's, well, that's off the graph there. So here's what this parent function would kind of look like, a basic one. And let's go ahead and let's apply what we know here, and we're going to see what happens to this graph when we do that. So if we take a look at the first bit, there's a reflection. So we need to take this point 0, 1 and reflect it. There's also a shift right by 2 and down by 3. So right by 2 and down by 3 would put that right there. Also, if you take a look at your horizontal asymptote, it's right here at negative 3. So we're going to go down 3, and then you can draw your helper line. Again, that's that asymptote. It's not really part of the graph, but it just helps us to draw the graph. And essentially what we're doing is we're taking this shape, we're flipping it, and we're going to draw it shifted right 2 and then down a little bit. So if you take a look at this point 0, 1, if we go left, we have to cut the distance between the asymptote and the next point by 1/4, or at least divide by 4. So we need to go left 1 and then up just 1/4. This one would be another left 1 and then 1/16. If you could graph it, it would be right there. If we go right 1, we need to go up 4 from the asymptote. So from this position, we go right 1, down 4. And then again, if we went over, slid over 2 units from that nice point 0, 1, we'd have to go down 16 from the asymptote. Not going to happen for us, so at this stage of the game, we can go ahead and draw the graph that looks a little bit like this. Oops, that got way off. It should be really close, actually. It should look more like that. Try to get it really close to the asymptote, but don't cross it. And we do need to analyze this thing. So if we take a look at the asymptote, it's the same as the vertical shift. So this is going to be y is equal to negative 3. Remember, a horizontal line, that's the one in red here, is going to be y is equal to a number. And you shouldn't just list negative 3. You should list an equation. An asymptote is a line is an equation. For the domain, anything really is possible for x. We can plug in whatever we like. So negative infinity to infinity. It's the same for all of them, for all these exponential ones. And then the range is going to be a little different. This graph exists from negative infinity up to, but not including negative 3. So we need to go from negative infinity up to, but not including negative 3. And that's it.